Hello friends, this is Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. And the last session was about introduction to the determinants, but the today's session is application of determinants. In this session, we are firstly going to discuss something about the properties of the determinants, and then we will extend our discussion that how these properties can be used to evaluate the area of the triangles. Apart from this, how to apply the Cramer's rule in solving the linear equations. So today's session objectives are about understanding the properties of determinants, evaluation of the area of triangle, and application of Cramer's rule. So to begin with, let's understand what do we understand about the properties of the determinants. There are different properties of the determinants. Likewise, we are having a transpose property, all zero property, proportionality property. So we will discuss all these properties in one by one manner. Now, the first property is transpose property, which says that the determinant remains unaltered if the rows are changed into the columns and the columns are changed into rows. That means a transpose is when we interchange rows into columns. Say we are having, look at the screen, say when we are having say A1, B1, C1, A2, B2, C2 and A3, B3, C3. Say this is a matrix, the equivalent determinant will be equal to A1, B1, C1, A2, B2, C2 and A3, B3, C3. Now, the value of this determinant will remain unchanged when we take the transpose. What do we mean by the transpose? When we change the rows into columns. So, when changing rows into the columns, say if this is equal to A, then transpose of A, AT will be equal to A1, B1, C1, A2, B2, C2, A3, B3 and C3. So, over here you will you may observe that this is first row and now this first row is changed into first column. So, we are changing the rows into columns and this is nothing but transpose. And if we calculate the determinant of A, and we will find that the determinant is equivalent to the transpose of the determinant of the transpose. Now, second important property is all zero property. The all zero property states that if all the elements of a row or column are 0, then the determinants are 0. So, if say we are having 0, 0, 0 and A2, B2, C2 and A3, B3, C3, then the result will be equal to 0. Or if we are having say 0, 0, 0, A2, B2, A3, B3, A4, B4, anything like that, then the result will be equal to 0. So, 0 matrix is a matrix wherein wherein all the elements are 0. So, if any of the rows or column is completely 0, then the result turns out to be 0. Then this is all about the all 0 property. Now, subsequently, we are having a proportionality or the repetition property, which states that if the element of a row or column are proportional or identical to the elements of some other row or column, then the determinant is 0. Now, in order to understand this, let's solve a numerical and say A is a matrix whose values are 2, 4, 6, 1, 2, 3, 7, 8, 9. Now, you can observe that row 2, that is this row, the elements are half of the values of the row 1, that is R2 is equal to half of row 1, because half of 2 is 1, half of 4 is 2, half of 6 is 3. So, if we calculate the determinant of A, we already learned that how to calculate the determinant of A. We firstly consider first row and first column, the intersection point is 2, intersection point is 2. The remaining value of determinant is to be calculated, that is 2, 8, 3, 9. So, 2, 8, 3, 9. Then the polarity goes plus, then minus, then plus. So, the second sign should be minus. Intersection, if I say that, let me first rub it out and then we can see that second element is intersection is happening at value 4, wherein the polarity varies from plus minus to plus. So, second sign should be negative. The intersecting value is 4 and the remaining determinant values are 1, 1739. So 1739. Similarly, this last intersection will be happening at point at the value 6. So this is the point. So plus minus plus. So the value is positive. Intersecting point is 6. So intersecting point is 6. Remaining determinant is 1278. 1278. Now we will separately evaluate each and every determinant. So if we have having this, so this is 2 into 9 minus 8 into 3. So 2 into 9 minus 8 into 3, 9 to the 18 minus 24, that is minus 6. Similarly, 1379, so this into this minus this into this. So 1 into 9 minus 7 into 3, that is 21. So 9 minus 21, that is equal to minus 12. Similarly, we are going to evaluate the third determinant and we will get the value minus 6. Now, if we put all these values at their respective positions, then what we are going to get? 2 into minus 6 minus 4 into minus 12 plus 6 into minus 6. If we evaluate the entire value, it turns out to be minus 12 plus 48 minus 36, which is resulting 0, because minus 36 minus 12 is equal to minus 48. So these values turns out to be minus 48, and minus 48 plus 48 is equal to 0. So I hope you understood this, that if the values are proportional, if the values of a determinant of or matrix are proportional, that means over here R2 is equal to 1 by 2 of R1, then the entire value of the determinant is nothing but 0. So this is the proportionality property, and let's move to the next property. The next property is scalar multiple property, which states that if all the elements of a row or column of a determinant are multiplied by a non-zero constant, then the determinants get multiplied by the same constant. So that means if you are having, say, some determinant A, say A, and we are multiplying each and every value of determinant A or with some value, or you are multiplying say some specific row with some constant K, then the new determinant B will be equal to K times of the value of determinant A. You will better understand this when we are going to solve this numerical. Say over here the given matrix is 2, 3, 1. This is A, the given matrix 2, 3, 1, 1, 1, 2 and 4, 5, 3. If we solve this, if we calculate the determinant of A, then it turns out to be similar the way we solve it in the last part, that 2 into the subdeterminant minus 1 into the subdeterminant plus 4 into the subdeterminant. Evaluating each and every value of the subdeterminant, we will get the respective answers. The respective answers are minus 7, 4 and 5. Now, substituting these values over here in this, say, equation number 1, then the result turns out to be 2 into minus 7 minus 1 into 4, 2 into minus 7 minus 1 into 4 plus 4 into 5. That turns out to be minus 14, 7 to the 14, 4 into 1 is 4, 5 for the 20, and we total the result turns out to be 2. Now, if we multiply the second row of matrix A with a scalar, say K is equal to 3, and we determine a new matrix B. So, if the second row is multiplied by 3, so if 3 into 3 is 9, 1 into 3 is 3, 5 into 3 is 15. So, new matrix B is 2, 1, 4, 9, 3, 15, 1, 2, 3, wherein the matrix A, second row of the matrix A is multiplied by constant value 3. Now, if we calculate the determinant B of the newly driven matrix, we get it 6, and this 6 value is nothing but 3 into 3 times of the determinant A. And what is this 3? 3 is our scalar value, this is our constant value K. So, I hope you are able to understand that if we multiply, what the property says, scalar multiple property, if all the elements of a row or column of a determinant are multiplied by a non-zero constant, then the determinant gets multiplied by that. Even if you're knowing that not all, if any of the any element of the row or a column, any row or column, you can say that by multiplied by constant, then again the value turns out to be the k times of the determinant A. Now, let's move to the next property. The next property is nothing but the switching property, wherein the property says that the interchange of any two rows or columns of a determinant changes its sign. So that means if we interchange the rows or columns interchange, then the value, then the sign is changed. Let's see how. Let's understand it with the help of an example. Now, say the matrix A is given to us. This is 3, 5, 7, 2, 4, 6, 1, 8, 9. We calculate the determinant of A, and the determinant of A turns out to be minus 12. Now, we interchange, say the interchange first row and second row. So, we are interchanging these two rows. So, that means 2, 4, 6 goes up and 3, 5, 7 comes down. So, by interchanging, we are getting a new matrix 2, 4, 6, 3, 5, 7, 1, 8, 9. And we calculate its value, the determinant value of new matrix A dash, the determinant value turns out to be 12. Whereas the determinant value of the original matrix A is 12. That means the sign is changed. Whatever sign was of A, inverse of the sign was for A dash. I hope you are able to understand this property. Similarly, if you are conversant with the properties which are discussed till now, you will be able to understand the sum property. The sum property is quite simple. We say that if we are having a determinant wherein the values are, say, like this, A1 plus B1, A2 plus B2, A3 plus B3, and the respective column values are C1, C2, C3, D1, D2, D3, then this determinant can be written in the form, say, A1, C1, D1, A2, C2, D2, A3, D, C3, D3, plus this entire plus is passed on here. And these entire values are passed on as a column over here, and these entire column values are passed on as a column over here. The remaining things will remain same. So, we can rewrite that A1 plus B1 C1 D1, A2 plus B2 C2 D2, A3 plus B3 C3 D3 as A1 C1 D1, A2 C2 D2, A3 C3 D3 plus D1 C1 D1, B2 C2 D2, B3 C3 D3. I hope this is clear to you. Now, apart from this, we are having a property of invariance, and this says that a determinant remains unaltered by adding a row or column k times some different column. So, if we say that there is a determinant A1 plus B1 C1, A1 B1 C1, A2 B2 C2, A3 B3 C3. This will remain same if we multiply one column, where over here what we had done multiplied column 2 with the constant k and added to the column 1. So, B1 is multiplied by k and added to A1, B2 is multiplied by k added to A2, and B3 is multiplied by k and added to. The value will remain same. You can try these properties by solving some of the numericals. And now we are going to some other important property, that is your triangle property. And the property says that if all the elements of a determinant above or below the main diagonal consists of zeros, then the determinant is equal to the product of diagonal elements. You can say that, say this is a upper triangular matrix, because the triangle of the non-zero values is happening on the upper side. Over here, the triangle of the non-zero values is happening at the lower side. So, this is a lower triangular matrix. So, the diagonal values are say A1, B2, C3, A1, B2, C3. So, if we evaluate, we need not to explicitly evaluate all the values. The property says that the result will be the product of the diagonal elements. that is A1 into B2 into C3. So if you are having any upper triangular matrix or lower triangular matrix, you just multiply the values of the diagonal elements and you will have the result of the entire determinant. So this is about the triangle property. Now let's try to apply these properties and solve some numerical. Likewise over here, say this is an example, show that determinant 1a square, 1b square, 1c square is equal to b minus a into c minus a into c minus b. Now, if we apply some of the row operations, likewise, we will be discussing about the row operations in the subsequent slides also explicitly in detail. But if we apply R2 such that R2 is equal to R2 minus R1. So, what is R2? Row 2 is 1b b square. And what is row 1? Row 1 is 1a square. If we subtract first row from the second row, then 1 minus 1, 1 minus 1, what will be the first value? 0. B minus a, the second value will be b minus a. Third value is equal to b square minus a square. So, b square minus a square, because R2 is such that it is R2 minus R1. So, this leads to the new determinant where the values are 1 a square, 0 b minus a, b square minus a square. And similarly, if we apply R3 such that R3 is equal to R3 minus R1, then we will, on the same lines, we will get the new value 0, c minus a and c square minus a square. I hope this much is clear to you. Now we further solve this problem by over here, because b square, if we say a square minus b square, then this is equal to a plus b into a minus b. This is standard formula. So, if I say this is equal to b minus a into b plus a. Similarly, this will equal to c minus a into c plus a. So, if we take b minus a common from the row 2 and c minus a common from the row R3, then what will happen? The remaining terms will be b plus a and c plus a. So, whatever remaining is b plus a and c plus a, and b minus a and c minus a are taken as common. So, the new determinant will be this b minus a will be moving out, this c minus a will be moving out, this b minus a will be moving out, and this c minus a will be moving. So, whatever is remaining is 1 a square, 0 1 b plus a, 0 1 c plus a. Now, I hope up to this step it is clear to you. Now, let us extend our discussion that how to solve this thing at. Now, the next part is that if we expand it along column 1, so what is column 1? Column 1 is this. So, after taking this part, the remaining determinant is this. So, we will be having 1 into determinant b plus a, 1 c plus a. So, solving this determinant, this into this minus this into this, that is equal to b plus a, this into this minus this into this. So, just wait for a moment. Yes, this is equal to c plus a, c plus a minus b plus a. So, c plus a minus b minus a. So, a will get cancelled out and we will be remaining with c minus a. So, if we substitute this value, we will get c minus a. So, the resulting value will be b minus a, c minus a, c minus b, and that was required to be proved. So, I hope you are able to understand that by applying the properties of the determinants, we can derive some of the, we can solve the determinants in an efficient and easy manner. Now, let us proceed our discussion to the next concept, which is about the area of the triangle. So this session is about the applications of the determinants. So first and the very common application is to calculate the area of the determinant of the triangle. Now say there is a triangle wherein the vertices are having the coordinates a x1 y1, b x2 y2, c x3 y3. Then the coordinates, then the total area, because the area of the triangle is half into base into height. Yes. So if I say x1, so x1, and in the opposite side we are having two values y2 and y3, so y2 and y3. So x1, y2, y3, y2, y3 this span. Similarly, next value is x2, next value is over here x2, and the remaining values are y1 and y3 are on the opposite side. So y3 minus y1. Apart from this, the next value is x3, x3. So x3 is over here. This is x3. So opposite values are y1 and y2. So y1 and y2. Now if we look into this, this is nothing but the determinant of the points. Say if I say this, if we solve the determinant, so value is x1 and y2 minus y3. So y2 minus y3, y2 minus y3. If we apply the same concept plus minus plus, then the next value will be equal to minus of this y1. Okay. So you will solve it, and or you may say that you may go column wise, apply the solution, and you will find that just by calculating the determinant value, wherein the coordinates are being supplied as input. That first input is x1 y1, the second input is x2 y2, and third input is x3 y3. So these are the coordinates of the vertices, and keeping the last column as 1. There is a logic why we keep the last column 1, because there are some coordinate systems, there are Euclidean coordinate system, there are homogeneous coordinate system. So we are not going to the details of those things, but you just keep into mind that x1 y1 are the coordinates of the one of the vertices, x2 y2 are the coordinates of the other vertices, and x3 y3 are the coordinate of the third vertex of a triangle, and the last column is kept as 1. Why it is kept as 1? It is out of the scope of the discussion, but there is a logic why we are having last column as 1. So by solving this, you will find that it turns out to be this value. So the area of the triangle is nothing but half of the determinant value, wherein the rows are the coordinates of the respective vertices of the triangle. Now, so there is an important observation that if we want to prove that the points are collinear, if say these are 3 points, these points are not collinear. Collinear points are those points which are lying on the same line. So if there are 3 points which are lying on the same line, then the area of the triangle should be equal to 0. So if the area of the triangle is equal to 0, that means the determinant value should be equal to 0. So if you are calculating the determinant of the values supplied for any triangle and it turns out to be 0, then you can say that the 3 points x1 y1, x2 y2 and x3 y3, they are lying on the same straight line, and that means the points are collinear. So this is one of the concepts. Now let's move to the let's solve one of the example problem. Now in this case, the problem given to us is that using determinants, find the area of the triangle whose vertices are 1, 4, 2, 3 and minus 5, minus 3. So as it is already given, say what is the area of the triangle? The area of the triangle is half of x1 y1 1, x2 y2 1, x3 y3 1. So we are given, this is the coordinates for A. So these are the coordinates for point A, these are the coordinates for point B, and these are the coordinates for point C. So we are passing on the values 1, 4, 2, 3, minus 5, minus 3. Now we solve the values as we have discussed how to solve a determinant. In the last slides, we get the value determinant is equal to minus 13. But if we take the modulus of the area can never be negative. So if taking the modulus of this, half of base into height, half of this determinant, half of this determinant, that means the area of the triangle ABC turns out to be 13 divided by 2 square units. I hope you learned that how to calculate the area of the triangle. And now we are going to solve some more problem, and this will let you understand the things in a better way. That if you want to say, we just discussed that if the area of the triangle turns out to be 0, then we can say that the points are collinear. So let's verify this. So with the help of an example, the example over here is that show that the point A B plus C, B C plus A, C A plus B are collinear. So in order to verify the collinearity, what should be the technique? You are supposed to check that the area of triangle should turns out to be 0. And what is the area of the triangle? That area of the triangle you already know. It is half of A1 B1 0, A2 B2 0, oh A2 A1 B1 1, A1 B1 and 1, A2 B2 and 1, A3 B3 and 1. Half of this value is your area of the triangle. So let's apply this concept to solve this numerical. So A is x1 y1 and which is A B plus C, B x2 y2 which is B C plus A, C x3 y3 which is C A plus B. Now putting the values in the determinant, A B plus C, B C plus A, C A plus B. Now if we use the property column 2 is equal to column 1 plus column 2, then by the proportionality property we can say that by applying this value, what is column 1? Column 1 is A B C, column 2 is this. If I add A to B plus C, we will get the value A plus B plus C. If I add B to C plus A, again I will get B plus C plus A. If I add C to A plus B, then again I will get C plus A plus B. And all these are nothing but A plus B plus C. So we can rewrite this as ABC, A plus B plus C, A plus B plus C, A plus B plus C. So that means we can take A plus B plus C is common, and because the columns are proportional, if we take A plus B plus C is common, then by using the proportionality property, we can find that the result is 0. And if the determinant is 0, then it is already proved that the points are collinear. So that this proves that by applying the property that the values are the points are collinear. I hope you are able to understand the application of determinant in calculating the area of the triangle. Now again, the next important concept which relates to the application of triangle is about the Cramer's rule. Cramer's rule is one of the most important technique which is used to solve the system of linear equation. Now before solving a system of linear equation, firstly we should understand what do we mean by linear equation. A linear equation is an equation wherein the variables are having the power of only 1. The exponent value is only 1. If the exponent value is 2, then we are having quadratic equation. If the exponent value is 3, then we are having cubic equation. We will learn about the quadratic equation and the cubic equation when we will be dealing about the unit of equations. Now let us consider 3 linear equation. First equation is this: a1x plus b1y plus c1z equal to d1. Now you see that the variable x, y, z all are having the power of 1. All are having the power of 1. If it is x square, say ax square plus bx plus c equal to say some 0 or whatever, then this is a quadratic equation because the power is 2. Max highest value of power is 2. Similarly, the next linear equation is a2x plus b2y plus c2z is equal to d2, and third linear equation is a3x plus b3y plus c3z is equal to d3. Now, what do we mean by the solution to the linear equation? Solution to the linear equation means finding the value of the variables x, y and z. So, you can say that uh, the set of values of x, y, z which make these three equations true, then this is those values of x, y, z are in fact the solution of the equations. So, again we are having different type of solutions. We are having consistent solutions, inconsistent solutions. We are having a homogeneous system of equations. We are having non-homogeneous system of equations. Now, if the right side of the equation d1, d2, d3 is 0, then such a system of equation is a homogeneous system of equation. And if they are not equal to 0, then such a system of equation is non-homogeneous system of equation. Apart from this, a system of equation which has one or more solution is called a consistent system of equation, and a system of equation which has no solution is inconsistent. We will learn about the consistent, inconsistent, homogeneous, non-homogeneous terms in the subsequent slides. Now, let us understand how to solve what is the technique in fact to solve the to solve the system of linear equation using Cramer's rule. So, this is a system of linear equation given to us. The system of linear equation is comprised of three equations: a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Now, if we focus on the coefficients of these equations, on the left hand side we are having the coefficient a1, b1, c1, a2, b2, c2, a3, b3, c3. These are the coefficients of the variables x, y, z. Now, if we gather them all together into a determinant, then we will get the value of delta, that is the determinant value, which is comprised of a1, b1, c1, a2, b2, c2, a3, b3, c3. Now, look over here that we are not involving value d1 or d2, d3 over here. Now, how to involve say d1, d2, d3 over here is when we are going to calculate the value of delta x, delta y and delta z. Now, when we are calculating for delta x, now x is happening at this position, that means at this position in delta. So, when we are calculating for x, we should replace a1, a2, a3 by d1, d2, d3. Remaining things will remain same. Then we will be calculating delta x. This is just a way to understand, just a way to remember that how to calculate delta x, delta y and delta z. Now, similarly on the same lines wherein the y values are happening, the y values are happening at the second row. So, second row over here is just yes. The second row, second column is this. So, in order to this is related to y. So, when we are going to calculate delta y, we should replace these values by d1, d2 and d3. Look over here, delta y. So, a1, a2, a3 remains same, c1, c2, c3 remains same, but these values are replaced by d1, d2 and d3 and we are getting the value of delta y. Similarly, on the same line of action, when we are going for delta z, then what we are supposed to do? We are supposed to say a1, a2, a3 will remain same, b1, b2, b3 will remain same, but the z values are happening at this position. So, this position is to be replaced, these positions are to be replaced by d1, d2 and d3. So, delta z value will be equal to this value, delta y value will be equal to this value, delta x value will be equal to this value. Now, if we are supposed to find what is the value of x, because the solution of linear equation is to find the values of x, y and z which satisfies all these three equations. So, the value of x will be equal to delta x, this is the value of this divided by delta. What is delta? Delta is this. Similarly, we are going to calculate the other values, that is your delta y and your y value and z value. The y value will be equal to delta y divided by this delta. Similarly, delta z will be equal to delta z divided by delta value. So, this is the method of solving the system of linear equations by using Cramer's rule. And just to let you understand in a better way, there is one more slide wherein this is a system of linear equation. The value of delta is a1, b1, c1, a2, b2, c2, a3, b3, c3. Then when we are calculating for delta x, the x value, that is a1, a2, a3 are to be replaced by d1, d2, d3. Then we are going for y values, then b1, b2, b3 is to be replaced by d1, d2, d3. Where what are d1, d2, d3 are the values which are occurring on the right hand side of these equations. And for delta z value, the c1, c2, c3 are to be replaced by d1, d2, d3. So, if delta is not equal to 0, this is very important because this is lying at the denominator. So, if this turns out to be 0, then the result turns out to be infinity. Okay. So, if delta is not equal to 0, the one of the important condition is that if delta is not equal to 0, then in that case we are having value of x is equal to delta x by delta, value of y is equal to delta y by delta, and value of z is equal to delta z by delta. Now, thereafter we are having some important observation that it must be noted that if delta is equal to 0 and one of the delta x or is equal to delta y equal to delta z 0, then system has infinite number of solutions. Why? Because delta turns out to be 0, and one of delta x delta is non-zero, the system has no solution. So, this is, and it is inconsistent. So, you will learn about these things when we are going to solve the numericals. So, let's solve some of the numericals now. Over here, say this is a system of linear equation. We are given a system of linear equation x plus 2y plus 3z is equal to 6, 2x plus 4y plus z is equal to 7, 3x plus 2y plus 9z is equal to 14. Now, you just firstly develop value of delta. Now, delta will be comprised of the coefficients of x, y, z, which are over here 1, 2 and 3. So, 1, 2 and 3, 2, 4 and 1, 2, 4 and 1, 3, 2 and 9, 3, 2 and 9. Now, solving this determinant, you will find that it turns out to be minus 20 and which is not equal to 0. So, that means we are ready to calculate x is equal to delta x by delta and y is equal to delta y by delta, and similarly z is equal to delta z by delta. So, now we calculate delta x. So, how we calculate delta x? So, we learned that when we are having the value say a1, b1, c1, a2, b2, c2, a3, b3, c3, then the values of a are to be replaced by d1, d2 and d3. So, then we will be able to calculate delta x. So, what will be delta x over here? So, delta x will be, the first column is to be replaced by the values of d1, d2, d3. So, d1, d2, d3 are 6, 7 and 14. So, these are a1, a2, a3. So, these values are to be replaced by d1, d2, d3 is 6, 7 and 14. So, these are replaced by 6, 7 and 14, and we are having now a new determinant wherein the columns are 6, 7, 14, that is d1, d2, d3. Then we are having C1, B1, B2, B3, B1, B2, B3 as 2, 4 and 2, and then we are having 2, 4 and 2. Then we are having C1, C2 and C3, that is 3, 1 and 9. So, 3, 1 and 9. So, these are the values for delta x. By solving these values for delta x, you will find that it turns out to be again minus 20. Similarly, delta y. Now, delta y, that means the second column is to be replaced by d1, d2, d3. Now, what are d1, d2, d3 over here in these equations? The d1, d2, d3 values are 6, 7 and 14. So, we replace b1, b2, b3 that is 2, 4 and 2 by 6, 7 and 14. So, 6, 7 and 14, this is replaced by this value. So, we are having delta y, which is a new determinant 1, 6, 3, 2, 7, 1, 3, 14, 9, and result turns out to be minus 20. Similarly, on the same line of action, delta z turns out to be wherein these values, that is C1, C2, C3, are to replaced by D1, D2, D3, D1, D2, D3, and we will have a new determinant 1, 2, 6, 2, 4, 7, 3, 2, 14, and it again turns out to be minus 20. So, to calculate the value of x, the Cramer's rule says you should calculate delta x by delta, delta x by delta. Y should be equal to delta y by delta, and z should be equal to delta z by delta. So, what is delta? Delta value is minus 20, and delta x is minus 20. So, minus 20 by minus 20, that is 1. Similarly, delta y is minus 20 and delta is minus 20. So, minus 20 by minus 20 is again 1. Similarly, delta z is equal to 1. So, the answer is x is equal to 1, y is equal to 1, and z is also equal to 1. I hope you understand that what is the Cramer's rule. Now, after going through this session, you can try the several problems which are given into the self-learning material, and you will find that you will be easily attempting all the questions which are going to appear into your term end examination, apart from this into your assignment so far as continuous assessment is concerned, and you will enjoy this subject because it is very simple. You just need to apply the concepts which are learned by doing the calculations on your own. Okay. So, in the next session, we will be discussing about some more details about the determinants and more concepts. Thank you very much.